Okay, pre-cal, here's your second page of your Unit 2 notes. We are going to continue talking about the end behavior of our polynomials. So there are two things that tell us about the end behavior. We use the degree, as you saw in those last examples in the last video, and we use the sign of the leading coefficient. And remember, the leading coefficient is the coefficient associated with the term that holds the degree, so the greatest degree term. All right, so I've made a little chart here for you. I call it the DOE, or the DOE chart. So our degree is either odd or even, and your lead coefficient is either positive or negative. And then this right here shows us what our end behavior would look like. So if we've got degree odd, leading coefficient positive, it's down, up. And then for odd negative, it's up, down. For even positive, it's up, up. And for even negative, it's down, down. If you will memorize that chart or write it each time you have to do this, then you can just refer to it. It's super easy. I'm going to use it for this right here. So these examples write the end behavior of the following polynomial functions using infinity notation. That's the one where we say x approaches infinity or negative infinity and y responds. Okay, so if you will look at this first example, we have an odd degree. Okay, so we're going to be looking at this right here. Odd is right here. So, and it's a positive, so it's odd positive. That means as you can see here, we've got down, up behavior. So what's happening as far as the infinity notation, this way is negative infinity for x. So as x approaches negative infinity, y is responding. Sorry, I should have written that to the side. Y is responding by also approaching negative infinity. And then up here, x is approaching positive infinity, y is approaching positive infinity as well. All right, so in example 2, we've got an even degree, and this is positive, so it makes sense that this is up, up. So here, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y also approaches positive infinity, just like that. Okay, in the next one, we have odd, and it's negative, so it makes sense that it's going up, down. So as x approaches negative infinity, that's what's happening here, because negative is this way for x. Y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. Okay, this last one here, we've got negative x to the 6th. Well, 6 is even, so and it's negative, so it's down, down. That makes perfect sense. So in infinity notation, as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, I'm losing it, y is still approaching negative infinity. All right, so let's apply that to all of these specific examples down here. Write the end behavior in infinity notation, so just what I did on those others, but now we've got to go through a little bit more, and we're also going to find the y-intercepts. Okay, so the very first thing we're going to do, since we're looking for end behavior, we need to know what our degree is, and we need to know our leading coefficient. So I'm going to do all of these the exact same way. The degree here is 4. So that's even, and my leading coefficient is negative. In this case, it's -1, but I don't really care with the value, I just care about the sign. So since this is even and negative, that means we have down, down behavior. So as x approaches negative infinity, y also approaches negative infinity. And as x approaches positive infinity, y approaches negative infinity as well, since it's down, down. All right, so we're also going to find our y-intercept, and this is super duper easy. If you'll notice, the y-intercept is when x is 0. So if this is 0, this is 0, and this is 0, we are left with -9. So there's your y-intercept. It's the constant. Okay, moving on to the next one. My degree here is 5, so that's odd. and my leading coefficient is positive, so that means that my end behavior is down up, and I'm just referring to the chart. Okay, so that means that as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. Do I need to think about the graph every time? No, I just need to refer to my up-down arrows, because the one on the left, okay, that's always going to be x is approaching negative infinity, and the one on the right is always x approaching positive infinity. All right, so my y-intercept for this one, 0, 6. Excellent. Okay, the next one. The degree is 3. So that's odd. And my leading coefficient is negative, so that means that my end behavior is up, down. So as x approaches negative infinity, y approaches positive infinity because it's up. As x approaches positive infinity, y approaches negative infinity. My y-intercept is 0, positive 3. All right, the next one, the degree is 6, that's even, and my leading coefficient is positive, so that means up, up behavior. It's on the up and up. Okay, so as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y still approaches positive infinity. And my y-intercept is 0, negative 10. Awesome. Okay, so for this number 9 right here, my degree is 8. That's even. My leading coefficient is a negative, so that means that I've got down, down behavior. So as x approaches negative infinity, y approaches negative infinity. As x approaches positive, y approaches negative. My y-intercept, of course, easy peasy lemon squeezy, is 0, negative 2. All right, number 10 is different because you can't see your constant. But it's going to be easy. It's not a big deal. All right, so when we look at this one, we don't immediately know the degree. So we have to stop and think about something. We have to stop and think about the fact that if we square this right here, that means that our highest degree term is going to be x squared, and it's going to get multiplied by 2x. So if I'm going to look at 2x cubed, that's going to be my term with my degree. So the degree is 3, and it's odd. My leading coefficient is positive, so that means my end behavior is down, up. So as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Okay, for our y-intercept, we've got to do some magic here because this doesn't look like we're used to, okay? We can't just look at the constant. Just let all your x's be zeros. So 0 plus 2 squared times 2 times 0 minus 1. So 2 plus 0 is 2, 2 squared is 4, times 2 times 0 is 0, minus 1, so 4 times negative 1. So negative 4, just like that. Have fun with it, kids. Have fun.